Few branches of science divide opinion as sharply as that championed by Professor David Keith. He's one of the preeminent geoengineers striving to find new ways to combat global warming by altering the way the sea, the clouds and the atmosphere work. This isn't a replacement, he says, for the political drive to reduce emissions. But is geoengineering a cost-effective emergency stopgap before the effects of climate change become irreversible? Or a dangerous leap into the unknown? Professor David Keith, welcome to Hard Talk.
Thank you. Great to be here.
Thank you very much for being here. Let's start at the start. What is geoengineering?
It's really two very different things which have come under the same name but have very little relationship to each other. One is ways that we would alter the amount of sunlight the Earth absorbs and so cool the planet, partly offsetting the effects of carbon in the atmosphere, and that's called solar radiation management, or in some technocratic way, SRM. And the other one is to take carbon out of the atmosphere, so-called carbon dioxide removal.
So it's both reducing emissions or dealing with the growth in emissions by taking the carbon dioxide out of the atmosphere, but it's also trying to prevent those emissions getting to us in the first place.
I'd say the thing that really is unusual and rightly scary is the idea that we can directly alter the climate by reflecting away some more sunlight. And that's scary because we have extraordinary leverage as humans. Our science technology, for better or for worse, has granted us that. So with very tiny amounts of money or effort, we could alter the world's climate by putting these reflective particles, say, in the stratosphere. And that has profound implications, right up to big geopolitical implications.
Let me, before we get on to solar radiation management, let me ask you about the carbon dioxide removal. A Royal Society report here in the United Kingdom back in 2009 said that no method of carbon dioxide removal has yet been demonstrated to be effective at an affordable cost with acceptable environmental impacts. And they only work to reduce temperatures over very long timescales. It doesn't sound as if at the moment it's feasible.
I think that's exactly right, and I can say that both as an author of that report and as somebody running a startup company trying to capture CO2 from the air. So it's inherently true that anything you do either to reduce emissions, which we must do if we want to avoid climate risk, that is, we must cut emissions around the world, or to take CO2 out of the air, inherently acts slowly because CO2 builds up in the atmosphere over a century. It's a long time scale.
So how far are we away from some sort of technology which could do this in a way that is effective, is not too expensive, will work in a way that can be rolled out across the planet?
So technologies for removing CO2 from the air, in this case I've got to speak as somebody running a small company doing that. I think there are small niche markets where I and some of my competitors might succeed soon. But I view our job as trying to build a tool which humanity may or may not use over the next half century. I don't expect to see really big application anytime soon.
In that case, do you think it is more exciting, this other idea of solar radiation management, where you try and in some way reflect the sun's rays away from planet Earth?
Exciting, I guess, is the word. I mean, it certainly presents more immediate security challenges and governance challenges in a way that's very different. I mean,
well, I want to come on to those, but I want to explore, first of all, the science of it, in terms of how it can work, whether it's feasible, how much it costs. Is SRM, solar radiation management, the path which looks as if it's more viable at the moment?
No, I think it's impossible to say which is better. The fact is they're both different tools that we need to try and manage the overall climate risk, just as is cutting emissions. And there's no way to say that one is better. They do different things in the climate system in different ways.
Explain to me, first of all, though, before we get into the pros and cons of it, how solar radiation management might work.
So conceptually, it's simple. The Earth is in some kind of balance where we absorb sunlight and we radiate it away as infrared. And what CO2 is doing by warming the climate is making it harder for that infrared to get out. If you reflect away a little more sunlight by adding reflective aerosols, tiny particles, say, to the upper atmosphere.
And how do you do that?
You could do it with aircraft, for example. The doing it is probably not the hard part, but you could use aircraft or other methods to deliver literally tons or millions of tons of very small particles to the upper atmosphere.
One way, sort of spraying them out at a high altitude.
Correct. And one thing this does is to mimic what volcanoes do, at least in some crude way. So large volcanoes put sulfur into the upper atmosphere, and those cool the planet.
Again, this Royal Society report that came out in 2009 did suggest that although this type of management might be, solar radiation management might be relatively cheap to deploy and simple in the way that you've described it, there are considerable uncertainties, I'm quoting from the report, about their regional consequences, and they only reduce some but not all of the effects of climate change while possibly creating other problems. How far do you recognise that?
Oh, I think that's absolutely correct, and indeed I've spent a lot of time trying to look at the environmental problems that it will create and the social problems. So, I mean, it's completely clear that you cannot perfectly compensate for the environmental effects of CO2 in the atmosphere by cutting sunlight. You may, and we haven't even proved that, be able to reduce some risks of CO2 in the air by this method.
Isn't there a problem, though, that you could end up with different effects in different parts of the world? I mean, you could, for example, find that although you're reducing the amount of sunlight and the amount, therefore, that the Earth is warming up, rainfall is affected in different ways in different parts of the world.
Absolutely, and again, we've spent a lot of time looking at exactly that and publishing papers on that topic.
Well, and what conclusions have you drawn?
So the conclusions is it is not exactly equal, just like climate change. So climate change itself, driven by CO2, is not equal. It affects different people, different industries, different parts of the biosphere in different ways, and so too, solar radiation management will not be equal.
I guess the problem could be that if you ended up or a country ended up having a scheme whereby they had solar radiation management over their country, but the effect was that the country next door ended up getting a lot less rainfall, which is one of the feared consequences of this, then you could almost end up with a cause for conflict. Yes,
I think this is precisely where the sort of hard geopolitical issues arise. I mean, to put it in a kind of crude way, whose hand is on the thermostat? Essentially, the scientists and technocrats, including myself, I guess, are helping to invent a thermostat knob. But it's much easier to invent the knob than to figure out who should be in charge of it in a world with many states.
No, indeed, and I want to come on to the governance, but I want to ask specifically about the science of this, which is how far can you tell whether the effects of solar radiation management are then going to cause perhaps a catastrophic loss of rainfall in a certain part of the world. At the moment, it seems to be hazy, this.
I think it's not as hazy as that. So using exactly the same climate models as we've used to estimate the problems with CO2 in the atmosphere, the underlying climate problem, we've applied those same models and same techniques to look at this. And the results so far, I have to say, look pretty good. That's why we're paying any attention to it. So in fact, the results look like for small amounts of SRM, it is remarkably even, more even than we expected, and the benefits in terms of reducing climate impacts are substantial.
Right. I mean, I'm quoting again from one recent study, Nature Geoscience, which suggested that engineered cooling of this sort would lead to a much bigger loss of rainfall in China than in India. That doesn't seem to tally with what you're just saying.
I think we're saying the same thing. I've been authors of a bunch of those studies. I mean, one of the issues is whether you're talking about doing it extreme amount, whether you're talking about doing enough SRM to compensate for all of the CO2 in the atmosphere or doing a little bit. And there's more evidence that doing a little bit would be beneficial than doing a lot. And there's no question that it's unequal, but the inequalities in practice, when you actually look at it numerically, don't appear so far to be that big. But all that folks like I am saying is that we should do more research to find out.
More research. I guess the problem with more research is that the research itself could lend itself to consequences which could be damaging. I mean, if you think about drugs trials, for example, the best drugs trials, by and large, are the ones that are done on the largest scale. If you do something like this on a very large scale, you could be talking about affecting huge swathes of the planet.
Yes, but at least at present, nobody's talking about that. So to me, in the near term, research means research with computer models and research where we test the effects, say, on the ozone layer of very small quantities of these particles, much too small to change the whole climate.
Forgive me for interrupting. You say computer models. Isn't one of the problems with the climate and studying the climate is that it's incredibly difficult to know exactly how it works. It is very difficult to model.
Sure, it's impossible to know exactly, but you can still learn a lot.
Fine, but this is at some point going to leap from the computer screen into real life, and that's the point at which there could be danger.
First of all, we need to make a decision to do that. I, at least, am not ready right now to say that we ought to do that. We need to do the other research first. If at some point it actually makes sense to do this, we would presumably start with very tiny amounts of aerosol, an amount less than a big volcano, and we would ramp it up very slowly, watching for ill effects and benefits as we did that over a decade or two. And you would monitor the system, and if you saw problems, you'd stop. That still doesn't guarantee you safety. There is no guarantee of safety here. But remember, the benefits are also large. So one of the most obvious things we understand about climate impacts is heat stress on crops. A bunch of the poor farmers in the world, the most likely impact they'll see from climate is that the peak temperatures reduce the productivity of crops a lot. And first order models that we've actually run with crop models suggest that SRM could significantly reduce that impact. And that's a big deal for a lot of poor people on this planet.
Given that you're talking about beginning at a relatively small scale, I'm wondering what your reaction is to the postponement of a study here in the United Kingdom. It was the SPICE project, the Stratospheric Particle Injection for Climate Engineering project, which was planning to send a balloon and a hose pipe a kilometre up into the sky as a possible precursor to this type of solar radiation management that you're talking about. That was postponed at short notice for a further 6 months of public consultation because there was a bit of an outcry about it. How did you think that was handled?
I think it's interesting because it's the first real opening up of the public debate. I personally never understood the point of that experiment. So that experiment's sole goal is to find a technocratic way to make it a little cheaper to get materials in the stratosphere. And the one problem we don't have is that this is too expensive. All the problems with SRM are about who controls it and what the environmental risks are, not how much it costs. It's already cheap. So from my point of view, I thought that was a very misguided way to start experimentation.
But my point is not so much the sort of the worth of the science, but more about the public outcry about it. I mean, if it was that benign, it must be a cause of concern for you that there was this outcry and a decision to postpone it for 6 months.
My job is to help say the science clearly and help people think about the governance. It's not to promote this. So actually,
well, it is in part to promote this. I mean, you're a great enthusiast for this, and as you said, you have your own private company, which is...
my private company works on a very different part of it, which doesn't suffer from these governance challenges.
But it is all to do with the issue of geoengineering. I mean, you know, it's an incredibly sensitive topic.
I absolutely do, but I actually don't think my job is to promote it. My job is to help clear thinking and clear knowledge about the tools we have to regulate climate risk, among them this one. And I'm perfectly prepared to find that results show that we should never do this.
Well, do you think in that case that the current climate, in terms of the political climate, is overheated? Or do you think it's actually fair enough that people might be very concerned about these sorts of experiments?
I think it's healthy that people are concerned. People should be concerned about cheap technologies that can manipulate the entire planet's climate. But don't be so sure which way the public outcry went. So we actually ran a survey almost a year ago now that took data, high quality data, from 1,000 people in the UK, Canada, and the US to try and understand public support for research on these technologies and what kind of political leanings influence people's decision to be for or against. And in fact, we found pretty broad support for research. So it's not clear that that is changed. What's clear is that some groups have been vocal trying to oppose, and I think it's absolutely reasonable that they should. These are hard topics.
But that particular opinion survey that you're talking about, it also came up with the finding that 64% of subjects agree that humans should not be manipulating nature in the way suggested by solar radiation management.
Exactly.
Well, that would suggest that there isn't particularly broad support at the moment for the theory behind this.
There's not broad support for doing it, and I think that's quite a healthy thing. I mean, I'm one of the people who, maybe starting 20 years ago, most helped to open the door to get public conversation going on this thing. My current fear is that the door will be kicked open and people will rush forward to do it too quickly. So from my point of view, given how cheap it is and the extent to which it looks like a quick fix, I am not eager to have the public run away in support. Indeed, I think that would be a disaster. Because if there was strong public support, people would do it, and they do it without adequate tests, without adequate control, and it would be a disaster. So I'm not in favor of immediate action here.
How do you think, in that case, the public can be convinced, given that there is, as we saw with this project in Britain, tremendous skepticism, even about research at what you say is a very, very benign level taking place to begin with? If this is a global emergency, as we're always hearing from climate scientists, global warming, and the lack of agreement on cutting emissions, surely it is important to move ahead quickly.
I don't think it's an emergency in an hour-by-hour sense. The more carbon we put in the air, the bigger the risk is. And we must begin to restrain emissions. That has to be job one. And I think we need to develop the technologies and the governance systems to understand whether we might use these in the future. Public opinion will evolve over a long time, and from my point of view, the goal is to try and make that public opinion be able to be shaped by facts as well as possible, and also shaped by people's values about nature, values about poor versus rich, etc. And I have no preconceived notion about what the right answer is, except that we look seriously at these options because there appears to be kind of prima facie evidence that they actually would provide remarkable level of protection, both for nature, which we don't otherwise protect very well here, and for some of the poor people in the world who will be most affected by climate change.
All that would be fine if it were just a question of looking at whether this science could be effective. Yeah. But of course, we also exist in a political world, and this is something that you say needs to work alongside a cut in emissions. The problem, the inherent problem with this technology, surely, even if it were to work, is that it would remove the political will for there to be agreement on a cut in emissions.
So the inherent problem with seatbelts is it removes some of the incentive to drive slower. Seatbelts also save a lot of lives. Is that really an argument against seatbelts? So first of all, if this technology works, and it may not, that's why you need to do research. If it works, it will limit climate risk in the near term. It doesn't substitute for cutting emissions in the long term. Are you really saying that we should wish not to have a technology which limits risk? Is a very odd moral quandary. We have rich people.
But forgive me for interrupting. Yeah. Your analogy with seatbelts sort of falls down on the grounds that there are laws to stop people from driving too fast. I mean, yes, of course, cars are safer with airbags and crash barriers and sidebar barriers and so forth. But there are laws to police that. The point about the cut in emissions is that there aren't laws. There is no agreement at the moment. There is repeated failure as far as multinational institutions are concerned in terms of agreeing that cut in emissions. You're removing the impetus, maybe not deliberately, but it is a side effect.
So, first of all, there are some laws. UK has actually made remarkable progress at beginning to have laws that put a price on using the atmosphere as a waste dump for carbon dioxide. I've spent more of my time in my life lobbying for laws on carbon dioxide than for geoengineering. So, to be clear. But I think this moral trade-off is a very puzzling one. So, if it works, and again, we don't know it does, it provides some protection in the near term. And I think it is a very odd moral stance to say we should wish that such protection isn't available, especially we in the rich world, when the consequences will fall mostly on the poor.
I can understand the moral case for it, but I'm talking about realpolitik here. I mean, when is a negotiation, in terms of very complicated negotiations between dozens, more than 100 countries, in terms of trying to get a global agreement, whenever is a negotiation going to be completed without that deadline hanging over them, people saying it is now or never, there is no plan B? The problem is you are, in effect, offering a plan B.
Yeah, and do you think it would be moral for us to pretend it wasn't there? Our job as scientists is to say all that we know clearly and to be honest about the trade-offs. And the trade-offs are hard. We can't pretend to the public they're not hard. But pretending away that we don't have those trade-offs is worse than not.
But you must, in that case, shudder slightly when you hear somebody like Newt Gingrich, a former Speaker for the House of Representatives, saying we would have an option to address global warming by rewarding scientific innovation, bring on American ingenuity, talking about geoengineering, stop the green pig.
Of course I shudder. I believe I'm the one who introduced the term moral hazard into this debate. I'm terrified about this outcome. But that is not, in my view, a reason to be silent about the fact that there are methods that might actually reduce risk on a reasonable timescale. And the fact is, the reasons why people ultimately do or do not commit to serious action on cutting emissions are not simple. And there is no simple rule that says that just because this is true, people won't cut emissions. The opposite is also possible. People's reaction may be, if the scientific techno-weenies are so concerned about climate change they're considering messing with the whole planet, then we should take it seriously and actually cut emissions.
You're chasing money, funding in part from Richard Branson, a $25 million pot of money that he's come up with. Are you slightly unnerved by the fact that Richard Branson himself, who owns the Virgin Airline Group, was quoted back in 2009 in the New York Times saying, If we could come up with a geoengineering answer to this problem, then Copenhagen, which was the UN conference at the time that was trying to agree limits on carbon emissions, wouldn't be necessary. We could carry on flying our planes and driving our cars.
Of course. I think it's a completely naive statement. It obviously isn't real because anything we do to pull CO2 out of the air is going to cost a lot of money.
And yet I mean, let's be clear here, you and your company are after Branson's money.
The cheapest thing to do is to use the atmosphere as a waste dump. And if we want to stop doing that, we must have laws that restrict the ability to use the atmosphere as a waste dump.
My question is, are you not concerned that you and your company, Carbon Engineering, is looking for money from people like Richard Branson? It's funded, I think, in part by Murray Edwards, who is a key figure in tar sands, which is seen as one of the dirtiest fuels on the planet.
It is.
Are you not slightly concerned about the people who you're getting into bed with?
Yes and no. I mean, Richard Branson I don't know. Murray I know reasonably well, and I don't share his view about what should be done about the oil sands. I think the oil sands should be regulated and eventually killed. So,
but do you not see, though, that these are people who see, perhaps, geoengineering as a quick fix?
Of course, but I also work with lots of environmental groups. My job is to work with lots of people and try and be clear about I'm very proud of attempting to bring what may be a useful tool, only one tool in many, to manage the global CO2 burden, to bring that tool into reality. I'm completely proud about that. And I wouldn't take money from cheats and liars, but I'm happy to take money from serious folks who have a broad set of interests. No problem.
Given the difficulty that there has been in terms of agreeing cuts in global emissions, isn't it also going to be phenomenally difficult, as you said earlier on, I mean, whose hand is on the thermostat, for there to be agreement as to what temperature is the right temperature for the planet? I mean, Russia and Canada, for example, might well want a slightly warmer environment, but islands in the Indian and Pacific Ocean presumably want a much colder environment so that they're not subsumed by water.
Let me tell you a real horror story. Let's say it warms up for a while, and people begin to explore for oil in the Arctic, which I personally loathe that idea because I love the high Arctic. Then those people who have, at that point, amount of capital at risk in the Arctic will not want the warming to stop because they'll want the warmer Arctic for that economic access. That's one of the lock-ins that really horrifies me. That's one of the reasons I think we need to begin to discuss these questions now. The world needs, sooner rather than later, to begin to think about the way these technologies would work. Remember, technologies evolve much faster than our ability to govern them.
But it could be extremely difficult for you, I mean, to control this if you come up with the technologies and countries start using them by themselves in a way that isn't subject to global governance.
Absolutely. So first of all, I should say, for work on SRM, on these very high leverage technologies that have security concerns, I believe there should be no private action, there should be no for-profit action. I believe it would make sense for SRM to actually restrict or eliminate the possibility of patenting. I think this has to be publicly controlled and publicly owned.
Isn't your company involved in several patents at the moment?
This is the difference. So for capturing CO2 from the air, that's an encapsulated small technology, which can be regulated by the normal laws. It's inherently expensive, so there's no risk of sucking all the CO2 out of the air because it costs so much. There's a public good, a global public good when you remove CO2 from the air. Any technology you have that removes CO2 will have local risks, maybe unacceptable risks, but those risks can be managed by the normal local risk management we have. This is very different from the technology of putting particles in the stratosphere. So I think that I'm happy to see private action on cutting emissions by making solar power or electric vehicles or capture from air. I'm not happy to see public action on technologies with this huge leverage, like putting particles in the stratosphere.
Let me throw one very last brief quote at you, if I may. It's from a man who's written a book, Ellie Kintish, about geoengineering. Geoengineering is a bad idea whose time has come. Do you share that emotion?
I think in many ways, yes. So there's no question we must cut emissions. And there's no question that some people, as you had the Richard Branson quote, imagine that we can just make all the technological fixes happen so it's free and we don't have to do anything. I think that's naive. We must cut emissions, but we still might want technologies to manage the risk separately from cutting emissions.
Professor David Keith, thanks very much for coming on HARDtalk.
Thanks a lot. Thank you.